equations by substitution. So we're going to solve using a new method. So we talked about solving these systems of equations using graphing, but now we're going to talk about a different method. I would say the best way to solve using graphing, or when to use graphing, is when both of your equations are in y equals mx plus b. But what if you have an equation that has just one of them in y equals? This is the best method to solve when you have only one equation that says y equals or x equals. So when you're solving, we talked about our options. One solution, no solution, or infinite solutions. So what that would look like with substitution is if you solve and you get an actual answer. You get what x equals and you get what y equals. That is when you have one solution. You will have an ordered pair, x comma y, as your answer. If you get something that looks like 0 equals 5 or 10 equals 20, something that is not true, that's when you'll have no solution. If you get something that is true, like 3 equals 3 or negative 1 equals negative 1, that is an example of infinite solutions, when they are equal to each other. So we're going to solve this first example using substitution. So we have y equals 6x plus 7 and 3x minus 8y equals 4. Our step 1 says start with the equation that is already solved for x or y. So we're going to start with this equation right here that says y equals 6x plus 7. And it tells us to substitute the variable that it equals into the other equation. So this is telling me that y equals 6x plus 7 no matter which equation we're in. So in this second equation, y could also equal 6x plus 7. So I'm going to substitute that 6x plus 7 into my second equation. So where that y was, I'm going to put 6x plus 7, and that y is completely gone. Just like if I had a substitute teacher, I would not be here. If you're substituting in for a letter, that letter will no longer be there. Then it says in step 2 that we need to solve for the variable that is left. Notice we only have x's left, so we can solve for x. So I'm going to start doing that by distributing this negative 8. So that's going to give me 3x, and negative 8 times 6x will give me negative 48x, and negative 8 times a positive 7 is going to give me negative 56. Then I can see that I have some like terms. My x's can go together. So 3x minus 48x is going to give me a negative 45x. Then to isolate that x, I can add 56 on both sides, giving me negative 45x equals 60. Then to finish it off, I see that negative 45 is times y, so I can divide by negative 45 on both sides. Now, if I need to figure this out, I can always use my calculator, and I need to do 60 divided by a negative 45, which is going to give me a decimal. I don't want a decimal again. I want fractions, so let's hit math, enter, enter. So I get x equals negative 4/3. That is part of my solution. Remember, if in our entire unit, when we're solving a system, we have to write our answer as a point. So we have found in our ordered pair that the x is negative 4/3. I still have to find what the y equals. that you found into one of the original equations. So I'm going to look at my original equations. I could use either one of these equations, but I want to make it a little easier on myself. I'm trying to find what y equals. I have an equation that says y equals 6x plus 7. So I'm going to plug into that equation. So right here, let's plug it in. And in this equation now, I know that the x is equal to -4/3. So I'm going to plug that in and find what y equals. So I'm going to plug this entire thing in my calculator, make it super easy on myself. So 6 parentheses -4/3 plus 7. And I get my y equals -1. There's the second part to my point, my x and my y. Now that I have my answer, I want to make sure that this is correct. So I'm going to write both of my original equations down. And I want to make sure that this point of -4/3, comma, -1 will work for both of my equations. So here's my other equation, 3x minus 8y equals 4. So let's plug in our x for as -4/3, and then our y we found was -1. So let's make sure that that works for our equation. So I'm going to plug this right side of my equation into my calculator. 6 times -4/3 plus 7 is equal to -1. So I know that this works for my first equation. I need to double check that it works for the other equation as well. So I'm going to plug in to my other equation. My x was -4/3 and my y was -1. So now I got to figure out if this left side of my equation does equal 4. Let's figure that out. So 3 parentheses -4/3 minus 8 times a -1. And it does. So since 4 equals 4 over here, it worked for that equation, and it worked for my first equation, that I know that my solution of -4/3, comma, -1 was the right answer. Okay, let's look at another example and let's practice this substitution method. So example 2, what is the solution to this system of equations? -3x plus 3y equals 4 and x equals y minus 3. So our first step is we always have to start with the equation that already is equal to x or y. So we see right here that we have an equation that says x equals y minus 3. So since x equals that, I'm going to plug all of that into my other equation where x is. So I'm going to write my new equation, and instead of putting x, I'm going to have y minus 3, and then the rest of my equation is going to stay exactly the same. Notice I only have y's in my equation now. So I'm going to try to solve this for y. I can do that by starting to distribute. -3 times y is going to be -3y. -3 times -3 is going to be +9. Then I see I have some like terms. My y's can go together. -3y plus 3y becomes 0. They cancel each other out, which leaves me with 9 equals 4. Well, does 9 equal 4? No, it doesn't. So this tells me that I have no solution. Since this was an untrue statement, 9 did not equal 4, I get no solution. let's look at example 3. What is the solution to the system of equations y equals 3x plus 1 and 6x minus 2y equals negative 2? So again, I'm going to start with my equation that says x equals or y equals. And I see that y equals 3x plus 1. That's the equation I'm going to substitute into my other equation. So since y equals that, I'm going to substitute this in to my other equation for y. So I'm going to rewrite it, 6x minus 2, and instead of y now equals 3x plus 1. And it still equals negative 2. So to start off, I'm going to distribute this negative 2. Negative 2 times 3x is going to give me a negative 6x. And negative 2 times a positive 1 is going to give me negative 2. Then I see that I have some like terms. 6x minus 6x becomes 0. They cancel each other out. So I'm left with negative 2 equals negative 2. And I know that negative 2 does equal negative 2. So that's going to give me an answer of infinitely many